Cooking didn't just change what humans ate, it changed what humans became. Think about that for a second. Really sit with it. You've heard the story of human evolution 100 times. The tools, the language, the big brain that showed up somewhere along the way and made us the species that builds cities and argues on the internet. But almost nobody talks about the thing that might have caused all of it. The thing that came before language, before complex tools, before any of the achievements we put in textbooks. A controlled flame. A piece of meat held over it. A moment so ordinary looking that it rewired the entire trajectory of what a human being could be. Here's the claim, and I want you to take it seriously. Cooking may be the single most important event in human evolution. Not language, not the invention of the wheel, not writing. Cooking. That's the argument Harvard primatologist Richard Wrangham has been making since the 1990s, and it crystallized into a book called Catching Fire in 2009. Wrangham's hypothesis is not a fringe position dressed up in academic language. It's built on fossil records, comparative biology, and the kind of logic that, once you hear it, you cannot unhear. The core idea is this: fire didn't just warm us and protect us, it cooked our food, and cooking our food restructured our bodies so completely that it eventually produced the brain you're using right now to process this sentence, which, honestly, is a little bit much to take in. We tend to think of our intelligence as something that arose gradually, mysteriously, almost inevitably, like we were always heading toward this. But Wrangham's reading of the fossil record suggests it wasn't inevitable at all. It was contingent on a specific behavior, a habit, one that some ancestor of yours picked up and passed on, and that changed the physical structure of the human body across hundreds of thousands of years in ways that are still visible in your skull, your gut, your teeth. You've never been taught this in school. Most people haven't. And that gap between how important this event appears to be and how little attention it gets is the thing that made me want to pull on this thread until the whole sweater came apart. So here's the question sitting underneath all of it. If cooking is really the engine of human evolution, when did it actually start? And what did it cost us to get there? Before any of that, though, before the fire, before the transformation, you need to feel what it was like to be the version of a human that hadn't figured any of this out yet. It's roughly 2 million years ago. You wake up before sunrise because something in the trees made a sound. Your jaw is enormous, not cartoonishly so, but noticeably, structurally massive, anchored by muscles that run all the way up the sides of your skull like a pair of thick rubber bands pulled tight. You're hungry. You were hungry when you went to sleep. You'll spend the better part of today doing something about that. What follows is not a meal. It's a shift. You chew for hours. Tough roots, raw tubers, fibrous plants, maybe some fruit if you're lucky. Maybe some raw meat if the group got fortunate yesterday. Modern chimpanzees, your closest living relatives, spend roughly 6 hours a day chewing. That's the baseline. That's what your body is built for. A long, grinding, relentless mechanical process that breaks down food your gut can barely handle even after all that work. Your digestive tract is huge. It has to be. Raw food is hard to extract energy from, and your body needs to run a very long processing line just to get what it needs out of every mouthful. The calorie yield is low. The time cost is enormous. And here's what that actually means for your life. There isn't much of one. There's no surplus, no leftover energy at the end of the day for extended social bonding, for experimentation, for sitting still and working something out. Your brain is smaller than yours is now. Not because you're less capable in some moral sense, but because a large brain is metabolically ruinous, and your body simply cannot afford it. A modern human brain burns roughly 20% of the body's total energy at rest. 20%. For an organ that accounts for about 2% of body weight. Running that thing on a raw food budget is like trying to power a city on a single wind turbine. Something had to change. That creature, the one with the massive jaw and the 6-hour chewing schedule and the body entirely devoted to the logistics of staying alive, shares somewhere around 98.7% of its DNA with you. You are almost the same animal. And yet you are sitting here, right now, thinking abstract thoughts while it spent its entire cognitive budget figuring out which roots weren't going to make it sick. The distance between that version of a human and this one isn't time. It's fire. So when did it actually happen? That's the question. And the honest answer is, we're not entirely sure. And the uncertainty is more interesting than a clean date would be. The oldest solid archaeological evidence for controlled fire use comes from Wonderwerk Cave in South Africa, a site where researchers found burned bone and plant ash in sediment layers dating back approximately 1 million years. 1 million. That's not a typo, and it's not a rounding error. The ash wasn't from a wildfire that swept through. It was concentrated, contained, in a cave, which means someone carried fire inside and kept it going. That's not an accident. That's a decision. Then there's Gesher Benot Yaakov in northern Israel, a site on the shores of an ancient lake where evidence of fire use appears in layers roughly 790,000 years old. Burned wood, burned flint, burned seeds. A lakeside camp where something was being heated deliberately. Neither of these sites tells us who did it first, or how. And here's where I find myself genuinely stuck in the best possible way. We don't know if the first controlled fire started from a lightning strike that someone was brave or desperate enough to approach, or from the friction of stone tools accidentally throwing a spark, or from something else entirely that left no trace. The origin story is gone. Whatever moment it was, and there was a moment, a specific one, with a specific individual, it didn't come with a record. Picture it anyway. Someone, somewhere, a very long time before Wonderwerk Cave, picks up a burning branch. Not to cook with, maybe just because it's warm or because it keeps something away in the dark. They carry it. They feed it small sticks. At some point, days later, years later, generations later, food gets close to the flame. Maybe it falls in. Maybe it's placed there on purpose. The food changes. It smells different. It tastes different. It's easier to chew. That's probably not how it happened in one clean sequence. It almost certainly wasn't one person, one fire, one revelation. It was messier and slower and more distributed than any story we can tell about it. But the evidence left in the rock at Wonderwerk says that by 1 million years ago, it was already a habit, already something passed down. The discovery didn't announce itself. It never does. What it left behind, though, that's written directly into your body, and that part we can read. Here's what fire actually did to the body, and this is the part that made me put down whatever I was doing and just stare at the wall for a minute. Cooking breaks down the cellular structure of food before it ever enters your mouth. Heat ruptures cell walls, unravels proteins, softens starches. By the time cooked food reaches your digestive system, a significant portion of the hardest work is already done. The result? You extract dramatically more calories from the same amount of food. A cooked sweet potato delivers roughly 30% more usable energy than a raw one. Same potato, completely different yield. Your body didn't have to earn the extra, the fire paid for it. So the gut starts to shrink. Not overnight, not in one generation, but across deep time, the digestive tract of the lineage that cooked got shorter, lighter, less metabolically expensive to run. It no longer needed to be a 6-lane processing highway. A smaller road would do. And here's where it gets genuinely strange. That freed up energy had to go somewhere. Think of the body like a company that had been pouring its entire budget into one enormous department. Call it digestion, the one with thousands of employees and a massive operating cost and a building that takes up half the campus. Fire walks in and downsizes that department by a third. Suddenly, there's budget left over. And the one department that had always been underfunded, always running lean, always doing more with less, the brain starts getting real investment for the first time. The fossil record shows exactly this. Homo erectus, the species most researchers identify as the likely first habitual cook, shows a noticeable jump in brain volume compared to earlier ancestors. The jaw gets smaller, the face flattens, the brain case expands. You can hold an Homo erectus skull and see the reallocation written in the bone. Less architecture devoted to chewing, more devoted to thinking. If this is the kind of thing that gets you, drop a like, leave a comment. It genuinely helps. Anyway, the teeth tell the same story. Earlier hominins had molars built for grinding tough, raw plant matter, broad, thick, heavily worn. Homo erectus teeth are smaller, more like yours. The hardware was being quietly retired because the software, fire, cooking, the externalized pre-digestion of food had made it redundant. One species, one behavior, a completely restructured body as the invoice. And the brain that started growing in that skull didn't just sit there. It started looking for things to do with itself, which turns out to be a problem and an opportunity that no one could have seen coming. None of this happened in isolation. That growing brain didn't just sit inside a skull and quietly expand. It needed somewhere to be, something to do. And what it found, what fire made possible beyond the biology, was other people. Picture a small group, maybe 12 or 15 individuals gathered around a fire after dark. Not huddled separately, not scattered across the landscape doing their own thing, but together, deliberately together. The fire is the reason. It's warm, it keeps predators at a distance, and it holds something that smells extraordinary. Food that's been changed by heat into something none of them had to spend 6 hours chewing. They're not eating on the run. They're sitting, staying. For the first time in the history of their lineage, there's nowhere else they need to be right now. That's a new situation for a primate. Completely new. Anthropologist Polly Wiesner, who spent decades studying the Juhoansi people of southern Africa, found something striking when she compared daytime conversations to conversations held around evening fires. Daytime talk was mostly practical, economic, task-focused, complaints about who wasn't pulling their weight. But firelight conversations were different. They were full of stories, narrative, people describing things that weren't present, events that had happened elsewhere, people who weren't in the group. The fire, she argued, extended the social day and changed what humans did with it. That's not a small thing. That might be where storytelling started. The campfire became the first dining table, the first meeting room, the first stage. And sitting around it required something that scattered foraging never did: trust. You had to be willing to stay in one place with these specific individuals, share what you had, and not bolt the moment something felt uncertain. Some researchers, including Wrangham, argue that this enforced proximity and food sharing is where pair bonding began to stabilize, where the earliest versions of family structure started to cohere around the predictable rhythm of a shared meal. There's something quietly staggering about that. The institution of the family, the thing billions of people organize their entire lives around, may have its roots not in romance, not in religion, not in law, but in the practical logic of who's sitting close enough to the fire to share what's cooking. The sounds they made to each other in that firelight, the calls, the gestures, the early vocalizations, those were getting more complex too. Not language yet, but the pressure was building. You have things to say now. You have a story. You have people who sit still long enough to hear it. Something was assembling itself around that fire, and it had no idea what it was becoming. Chimpanzees understand fire. That's not a loose claim. It's been studied directly, and the results are genuinely strange to sit with. Primatologist Jill Proutz documented a population of chimpanzees in Senegal who lived in an area with frequent wildfires. These chimps didn't panic and flee the way most animals do. They watched the fire. They tracked its movement. They anticipated where it was going and moved to stay ahead of it, calmly, with what looked a lot like comprehension. One researcher described their behavior as understanding the dynamics of fire. They were not afraid of it, they were reading it. And then they walked away, every single time. No chimp has ever been documented deliberately feeding a fire. None have held a burning branch to something edible and waited. The gap between understanding fire and using fire to transform food is, apparently, one of the largest behavioral distances in the animal kingdom, and it sits right between us and our closest relatives. For a long time, the assumption was that this was an intelligence gap. Chimps just weren't smart enough. But that framing has quietly collapsed under scrutiny because chimps are extraordinarily intelligent. They plan, they use tools, they deceive each other with genuine sophistication, they pass learned behaviors across generations. The gap isn't raw cognitive power. It's something else. What it seems to be, and this is the part I keep turning over, is a specific combination of traits that only assembled in one lineage. Curiosity about fire without terminal fear of it. The patience to tend something that doesn't immediately reward you. The capacity for forward planning across a long enough time horizon to connect heat applied now to food improved later. And crucially, the social machinery to teach that connection to someone who wasn't there when you figured it out. Every one of those traits exists in fragments in other species. Crows plan ahead. Chimps teach tool use. Elephants show curiosity. But the full set stacked together in one animal at the right moment in evolutionary history, that appears to have happened exactly once. Out of somewhere between 8 million and 10 million species currently alive on Earth, and the uncountable millions that came before, one crossed this line. One developed the habit that restructured its own body, built a new kind of social world, and eventually produced every technology that followed. It's not a comfortable thought, actually. It's the kind of thing that sounds like flattery until you realize it's mostly just a description of a very specific accident. We didn't earn this. We stumbled into it. And the stumble changed everything. Which brings you back here, right now, wherever you're sitting. The brain you're using to follow this, the one pulling meaning out of sounds, connecting ideas across time, feeling something faintly like awe or skepticism, or both at once. That brain is a direct physical consequence of a fire that someone kept alive somewhere in Africa roughly 1 million years ago. Not metaphorically, structurally. The neurons firing right now exist in a skull that is shaped the way it is because cooking freed up the energy to build it. You are, in a very literal sense, made of heat. That's the thing I couldn't shake when I first went deep on this. We talk about human identity, what makes us us, in terms of art, language, consciousness, love. All of those things are real. But underneath every one of them is a gut that shrank, a jaw that got smaller, and a brain that got the budget it needed because someone held food over a flame and noticed what happened. The next time you sit down to a cooked meal, you're not just eating. You're participating in the oldest continuous human ritual still practiced anywhere on Earth. Older than any religion, older than any language we can reconstruct, older than agriculture, older than pottery, older than every civilization that has ever risen and collapsed and been excavated and argued about in academic journals. The shared cooked meal predates all of it by hundreds of thousands of years. And it still looks basically the same. Heat, food, people close enough to pass something across a table. There's a small group sitting around a fire right now, somewhere in the world, in the same configuration that your ancestors held for 1,000 generations before writing existed. And the thing that's changed is almost nothing. The fire is maybe a gas burner. The food is more varied. The sounds they're making to each other have become one of roughly 7,000 languages. But the shape of it, gathered, warm, fed, together, that's the same shape it's always been. You came from that fire. The thoughts you're having right now were built by it. The face you see in the mirror, flatter, smaller jawed, with that high, rounded forehead, is the face that cooking made. It started with one ancestor who didn't walk away from the flame, who stayed, who fed it, who noticed that the world on the other side of heat was different and better and worth staying close to. You're still there. You never really left.